Hello, today we'll discuss the PN junction, that is its forward bias and reverse bias when it is connected to the battery, and its VI characteristics, that is forward bias and reverse bias. So this is the P-type material, this is N-type material, and when this we have do such type of the connection, it will form the junction between the P and N-type, and its ends are connected to the battery. P is connected to the positive terminal, N is connected to the negative terminal. So here we can see that this N type material is having majority charge carrier of electrons, whereas on this side, P side, the majority charge carriers are holes. So these holes, they do not see the electrons there, and they try to drift to the N side. Similarly, electrons, they do not see the holes on the P side, and they try to drift in the P side. So in this way, there will be the exchange of holes and electrons along this pair. So this layer will definitely become a little bit shorter, and therefore there will be the flow of electrons will be there from the N side to the P side, whereas the current will flow from the P side to the N side. Okay, so this is the forward bias. So when it is a reverse bias, the P, in case of the reverse bias, the P junction is connected to the negative terminal of the battery, and the N type is connected to the positive terminal of the battery. So this is the space charge region is again here. Now in this case, we are taking more electrons from this side, and we are giving more electron in the, this is the P side, this is N side, and we are taking the electron from this sides, and you are giving more holes in this region. So in the reverse bias, what happens? There is the depletion layer is formed between the near the junction. So here the number of electrons will be layer in this case, and because we are taking more electrons from this side, and here the number of the holes will increase here. So when such situation will prevail, what will happen? The situation will be like this. In this case, we can see that there the layer of the electrons on this side is increases, and the layer of the holes on this side increases. So this is called as the depletion layer, or this is called as the space charge region. So this is actually unsaturated state, where when this layer increases, there is hardly the flow of electrons or holes from one junction to the another junction, and this is creating just like a barrier between the P and N junction, and that is the reason the no electrons will flow from one side to the another, and no holes will flow from one side to the another, and that's why this is the reverse condition. Means in this case, this diode will not act in the reverse condition. That is the reason. Now the characteristics, VI characteristics of this forward bias and reverse bias is like this. So this is a current on this side, and this is the voltage, and therefore this is actually the forward bias. When you apply the voltage to the P and N junction, and this is the reverse case. Okay. So in forward case, we have to apply initially we have to apply the voltage, and then after some time the current will flow in the diode. But in the when the we connected, when the diode is reverse bias, what happens? Because of this depletion layer is form of the longer length, and therefore there is no flow of the electrons or holes from across the junction. Therefore there will be no current flowing through the circuit. Okay, but the final condition is this, where the current flow will increase here. That is called as the breakdown, and this is VI characteristics of the diode. Thanks very much for watching this video.